Record progress.
Question 13 says, in the diagram below, a house is in the shape of a prism with a rectangular shaped roof with one side CN of 10 meters. The vertical tree is growing at a point T in the garden. NCST is equals to 65 degrees, CNT is equals to 69 degrees. The angle of elevation of the top from point C is 43.5. Is it possible for the tree to hit the house if it falls? So what we're going to do is imagine that the tree is falling down and compare the length of the tree to the length available for the tree to fall down. So the first thing we want to do is calculate the length of the tree. We are told that the elevation towards that over here should be at 43.5. But we need one side in order for us to calculate this length over here, which is CT. So the first thing we're going to do is we're going to calculate this angle here because we require it to use the sine formula. So the angle T in the triangle CNT is equals to 180 minus 65 minus 69, giving us 46. Okay, now that we have that, we will say, if we want to calculate this side, we require the angle, that opposite angle, and we will use that angle and that side for our sine formula. So we have here 10 over sine of 46 should be equals to CT over sine of 69. We will multiply both sides by sine of 69, multiply both sides by sine of 69, and we get that CT is equals to sine of 69 over sine of 46, and everything multiplied by 10, giving us a value of 12,978 meters. So now we know that length over there, and that would allow us to get 80 because we will just use our trig ratio. We know that angle over there, which is that. So we have this side, which is our adjacent. We're looking for the opposite. We're going to use 10 because it possesses both of them. So we'll say 10 of that angle, which is 43.5, is equals to our opposite 80 over CT, 12.978, and we will have AT is equals to 12,978 multiplied by 10 of 43.5, giving us a final value of 12.3, and that is then the height of our tree. So let us assume that when the tree falls, it will fall perpendicular to the line CN, right? So we need to find this available space, how the length of this available space, to see if it's greater than the height of the tree or if it's smaller than the height of the tree. So to get that, we have this side, we have that angle. We can calculate this by using our sine, right? We'll say that the sine of 65 is the opposite. We'll call it H. They call it X in our book. Let's call it X over our hypotenuse, which is CT, and the value of that, we calculated it to be 12.978. Therefore, X would be 12.978 multiplied by sine of 65, giving us 11,76. So we can clearly see that the available space is very small, meaning if the tree falls, it will definitely hit the house. So then we will make a conclusion and say the tree will hit the house.